Now I will create a PCG graph and drag it into the level. Create a new folder and name it PCG. In the PCG folder, right-click. Scroll down to the PCG section and select PCG graph. I will name it PCG landscape. And since this landscape is simple and has no layers, I will name it basic. Press enter and open this graph. Currently, there are already 2 nodes in the graph. The way the PCG graph works is a bit different from the blueprint graph. Return to the level. Now I will drag this PCG graph into the level. As you can see, this actor automatically creates a volume. In the outliner, I now have a new actor named PCG Basic Landscape. The name of the actor matches the name of the PCG graph. And in this actor, there is a PCG component. The volume you see is the brush component, which defines the PCG's scope. In the PCG component, I scroll down to the Graph Instance section. I can change the PCG graph. Since I dragged the graph into the level, it is currently using the basic landscape graph. I will change the graph. Create a new graph and name it test graph. Save it in the PCG folder. I have just created a new PCG graph, and it is used for the PCG component. Now I will switch back to the basic landscape. I search for basic landscape. I select basic landscape again. I delete the test graph. I was just testing. I can change the size of this volume in the detail section. Scroll up, set the scale to 50, 50, and the height to 40. Return to the graph. I drag out the left tab. This panel has all the PCG nodes I need. I need to get the landscape data. The node I need is Get Landscape Data. You can right-click and find that node. Or you can find it in the left panel. It will be in the Spatial section, there is a node named getLandscapeData. Additionally, you can get data from various sources, such as getActorData, getSplineData. Since I am working with the landscape, I will use getLandscapeData. And because I want to create many points on the surface of the landscape, I need to make this volume touch the surface of the landscape. If the volume and landscape do not touch each other, I cannot create points on the landscape. So I will drag this volume down until it touches the landscape. Currently, I am just getting the landscape data. I have not performed any actions yet. So in the next videos, I will create random points on the surface of the landscape. In this video, I will create random points on the surface of the landscape. From these points, I can generate trees or other objects. Go to the graph. From the landscape data I have, I'll drag it out. Then, I call a node named SurfaceSampler. True to its name, this node will create random points on the surface, and in this case, it's the surface of the landscape. Currently, I don't see any points. That's because I haven't enabled the debug for this node yet. I will right-click and select Debug here, or press D on the keyboard. The blue circle means I have enabled debug for this node. On the level, I can see the random points on the surface of the landscape. In some cases, if you don't see these points, click here. Click on Basic Landscape. Basic Landscape is the actor corresponding to the name Basic Landscape. And I will debug based on the PCG component. You just need to click on this debug icon. PCG component. In some cases, you might want to drag this tab down to see it better. Now, click on the level and press F10 on the keyboard. You can press F10 to hide and show the outer interface elements. For now, I will dock this tab up. When I right-click on this node, there is another function called Inspect. Or press A on the keyboard. And I have a yellow circle indicating I am inspecting this node. I am viewing the information from this node. Below, there is a tab named Attribute to display all the information of each point I have created. If you don't see it, similarly, click here. Click on this debug icon, and the tab will appear. Because if you don't click on debug, you won't see it, regardless of whether you inspect or not. After inspecting, remember to click on this debug icon. Below here, we have information such as position, rotation, scale. Here we also have color. However, I haven't used this attribute yet. Attributes like density and steepness. I will explain in later videos. For the density attribute, if density is 1, the points will be white. And if density is 0, the points will be black. And in between is gray. Currently, these points are generated randomly. But I can change that randomness. Click on Surface Sampler. And here, there is an attribute named Seed. If I change the seed, I will generate a different version. With the Surface Sampler node, I can control the number of points generated, which is the points per square meter attribute. I just need to change this number. For example, divide by 2, which means 0.05. Then I have fewer points. Reduce to 0.01. Or adjust back to 0.05. The second attribute is looseness, which means the distance between each point. I will set it to 2 units apart instead of 1 unit. If I set it to 5, the points will be even further apart. In the case of trees, I will set it to 5. But if you want to spawn grass or foliage, I will set a lower looseness value because the grass will spawn closer together, such as 0.5. But for trees, I will set it to 5. Point extents is the size of the point. Now I will change from 100 to 50 for X and Y. You can see these points have become smaller. Or if it's 200, they will be larger. The size of each point also affects the number of points. The smaller the points, the more points there will be. For example, with a size of 50. In cases like grass in the game, I will set it to 10. Or 5 like this. Currently, I only care about the X and Y values, while the Z-axis will stay the same. I will reset this value. I will dock this up. As I mentioned, changing these values will affect the number of points. Suppose I set point extents to 10. The number has increased significantly. Or if I reduce looseness from 5 to 1, the number of points will also change. Or adjust points per square meter from 0.05 to 1. The number of points will also change. I will set it to 0.05 and looseness to 5 for trees. There is another attribute called unbounded, which means currently I am generating these points within the limits of the PCG volume. This volume, if I tick unbounded, it will not be limited anymore. I have spawned the points across the entire landscape surface. Note when using unbounded, because it is not limited, if the landscape is large and the number of points is high, it will take a lot of time to generate the points, and Unreal might even crash because of spawning too many points. Currently, I have spawned over 1,700 points. So, I will uncheck Unbounded. In the previous video, I created random points on the surface of the landscape. From these points, I will create trees. Now, I will go into the Epic Game Launcher to download the trees for the project. I am currently in the Epic Game Launcher. Go to the Marketplace. Search for Black Alder. I select Megaskin Tree Black Alder. If you haven't downloaded this asset yet, download it. Then I will add it to the project. This asset only supports version 5.3. I am using 5.4. But I can still add it to the 5.4 project. I select Add. Because it only supports 5.3. When I look for PCG, I don't see my project. So, I will select Show All Projects. I select my PCG 5.4 project. Since version 5.4 is not supported, I will choose the closest version, which is 5.3. I select Add. After adding it to the project, I will return to the Unreal Editor. Now I will go to the Content drawer. Before doing anything, I will drag this folder into the Asset folder and select Move here. After moving it, I will go into the Asset folder. Go to Black Alder. The trees I need are in the Geometry folder. There are two versions here, Pivot Painter and Simple Wind. I will always use the Pivot Painter version. These are my trees. First, I need to ensure these trees have Nanite enabled. I press Ctrl A to select everything. Right-click. Nanite. The trees from Megaskin already have Nanite enabled. I will use Forest 3, 4, and 5. Return to the PCG graph. From the surface sampler result, I will drag out and call the node Static Mesh Spawner. Here, there is a node called Static Mesh Spawner. This means that at each point, I will create a static mesh. I need to create a mesh entry. Create an element. Open this element. Open the descriptor. Select Static Mesh. I will find Pivot Painter. Forest 03. Black Alder Forest 03 Pivot Painter. Return to the level. These trees have been spawned. In the previous video, I used the static mesh spawner to create these trees. However, I only had one type of tree. Open the PCG graph. Currently, in the static mesh spawner, mesh entry, I only have one entry. Therefore, I will create 2 more entries to have 2 more variations. I find the static mesh quickly. For index 1, I use forest04. For index 2, I use forest05. Returning to the level. Now I have more types of trees. I can also change the selection rate of each type of tree. Back to the graph. In the mesh entry section, I have 3 entries. And in each index, I have an attribute called weight. All 3 have a weight value of 1. The total weight is 3. This means the selection rate of forest03 is 1/3. 04 and 05 are also 1/3. All variations have the same selection rate. If you want 03 to be selected more often, then change the weight to 3. So, the total weight will be 3 plus 1 is equal to 5. Therefore, the selection rate for 03 is 3/5. You can see that trees of 03 appear more often. I will set the weight of 04 to 2. So, the total weight is 3 plus 2 plus 1 is equal to 6. The selection rate of 04 is 2/6. For 03, it is 3/6. 05 has the lowest selection rate of 1/6. If you increase the weight of 05 to 100, the selection rate will be 100/100/5. And most of the trees will be 05. I will set the weights to 3, 2, and 1, respectively. In this video, I will use the node to transform points. First, I go into the PCG graph. Currently, I will disable the static mesh spawner node to focus on processing the points. You can right-click and uncheck Enable, or press E on the keyboard. E stands for Enable. Now the trees in the level will no longer spawn. I select the surface sampler and press D to debug. You can see that these points have the same scale values, and the rotation values are the same as well. Now, I will change the transform of these points. I remove this link before calling the static mesh spawner. I will change the transform. Select transform points and link it in. Please note that I am debugging based on the surface sampler node. So I will cancel the debug and debug the transform points node. First, I will change the scale. I will enable this node. Now, I will play the game to feel the size of the trees in the game. To change the scale value of the trees, for instance, if the tree is too big, I will decrease the scale, or if the tree is too small, I will increase the scale. I will set the scale from 0.8 to 2. Select Transform Points. The minimum scale is 0.8. The maximum scale is 2. The result after scaling is random. It will multiply the current size of the tree by this scale value. If the scale is from 0.8 to 1, it will look like this. If it's from 0.8 to 2, it will look like this. Because there is randomness, changing the seed will create new variations. For now, I will hide the static mesh spawner node to track the points more easily. Here, I have already changed the scale for the points. And now I will change the rotation. I will change the z-axis value. The z-axis is the vertical axis. I will set a random value from 0 to 360 degrees. And here is the result. Note that I am debugging based on the Transform Points node, and I can also debug both nodes. This is the result before and after the change. I can compare these two nodes by debugging both. I will hide the debug of this node. And I can change the offset value. I enable the static mesh spawner node again. Stop debugging this node. And I want the positions of these trees to be lowered. I will set a random offset from -5 to -10. I have finished with the Transform Points node. You can right-click on the Transform Points node and uncheck Enable to see the result before and after using Transform Points. Here is the result without using Transform Points. And here it is after using Transform Points. You can compare before and after using the node by disabling and enabling this node. This is before using. And this is after using. Currently, you can see that the landscape surface is quite flat. What will happen if the landscape surface has more slopes? I will switch to landscape mode, select Sculpt, and raise the terrain like this. You can see that after changing the landscape surface, the PCG graph has not been updated yet. I will click Force Regen to regenerate the points on the landscape surface. These trees depend on the landscape surface. If the surface is sloped, the trees will slope too. There is a way to change this. For highly sloped surfaces, I will not spawn points for trees. Or you can select Transform Points, and whether the points tilt or not depends on the rotation. The final rotation result depends on the landscape surface. If I select Absolute Rotation, the rotation of the points will no longer depend on the landscape surface. And you can see the trees are straight. But I don't like this solution because there will be these points and parts showing like this. So I will not select absolute rotation. Another solution for sloped terrain is to not spawn points there. I will only spawn points on flat terrain like this. And I will guide you on how to do this in the following lessons.